Now, having obtained an overview of the content framework, let's now go deeper to understand architecture content metamodel, which forms part of the TOGAF content framework, by the way. So first, what is a metamodel? A metamodel is a model that describes a model, or in other words, it defines what can constitute a model and any rules around how a model can be put together. Hence, going by that definition, the TOGAF content metamodel defines what can constitute an architecture model, and it describes the formal rules governing the structure, relationships, and use of various constructs that form part of the architecture model. It is important to understand this because if you ever use an enterprise architecture tool that supports TOGAF for modeling your enterprise architecture, these software products are based on the content meta model in order to ensure that consistent set of definition and rules are followed in the construction of architecture models within them. In order to be relevant to most instances of enterprise architectures, the content meta model is split into two parts, one forming the core of the meta model, which supports modeling elements that represents the common denominator that will be applicable to most enterprises and enables traceability across architecture artifacts. The other part is composed of several extensions, each supporting more in-depth modeling of a certain aspect of the architecture that can be picked up as required to tailor a content model that is best suited for an enterprise. The modeling entities or concepts used in the core content meta model are as follows. An actor, which represents a person, organization, or a system that is outside the consideration of the architecture model but interacts with it. An actor can assume roles to perform a particular task within the architecture model. An organization is a self-contained unit of resources with line management responsibility, goals, objectives, and measures. A function instantiates a business capability. A business service supports business capabilities through an explicitly defined interface. A process is a flow of interactions between functions and services, and hence cannot have an independent existence in the absence of functions and services that it orchestrates. Application component is an encapsulation of application functionality. Data entity is an encapsulation of data that is recognized by business domain experts as a discrete concept. Data entities can be tied to applications, repositories, and services. Platform service, a technical capability required to provide enabling infrastructure that supports the delivery of applications such as the .NET platform or the Node.js platform, or a cloud-based platform as a service offering. Technology component is an encapsulation of technology infrastructure that represents a class of technology product, such as, say, an infrastructure as a service offering on the cloud, a network firewall, or say a storage area network, for example. So to represent how these relate to each other visually, we can say that an organization can have number of functions. A function may be implemented using one or more business services. The business services can be composed of other business services and realized as an application component within the application's architecture, which in turn is implemented on a technology component that runs a platform service and is part of the technology architecture. An actor who is part of an organization may assume a role while interacting with a business function exposed via a business service. A function may encapsulate a process that may orchestrate a flow across one or more actors, business functions, spanning one or more organizations. Let's now get a brief overview of what each extension has to offer. The motivation extensions offer a more effective definition of service contracts and better measurement of business performance through more structured modeling of the drivers, goals, and objectives that influence an organization. The process modeling extension is intended to allow detailed modeling of business processes. The governance extensions provide constructs to capture additional structured information to support operational governance of the enterprise architecture landscape. The key aspects covered by the extensions include the structured definition of service levels, operational impacts, system and data ownership, dependencies between systems and business operations, and so forth. The service extensions provide constructs that define information system services in addition to just the business services defined in the core content meta model. Information system services align directly with the application components and hence enable business services to be abstracted from technical implementation considerations. Data model extensions extend the data entities in the core meta model by adding the concept of data components, which form a logical or physical encapsulation of the abstract data entities into units that can be governed and deployed into the applications. Infrastructure consolidation extension is intended to be used in landscapes where the application and technology portfolio have become fragmented, and the architecture intends to consolidate those capabilities for greater efficiency or for reducing complexity and cost. The Content Metamodel section of TOGAF specification goes on to describe a collection of Content Metamodel objects and their attributes, which can be used to create formal architectural models. And this is typically used by the enterprise architecture tool vendors to implement their modeling tools. It is beyond the scope of this course to go into those details, but feel free to browse the TOGAF specification for more insights into this area.